Okay, so now that we've talked about transition metal properties and transition metal complexes, we also need to talk about, actually, nomenclature. So when we talk about the nomenclature for transition metal complexes and transition metal complex compounds, then you should be aware, as with any ionic compound, we always name the cation first and then the anion. So that's the same for our complex compounds. Okay, and what we're going to do now is we'll go through the rules, and therefore the complex ions, we're going to focus first on the rules for the cations, and then talk about it's just a small, minor variation for the anions. So just so you know that this will apply to both, but we just have to tell you how to name the anions. So for complex ions, when you name them in either case, you always write the ligand names before the metal followed by the oxidation number. And the ligands are going to be listed alphabetically. There are prefixes that we use in order to specify the number of the ligands, but those are not included when we list them alphabetically. When we do ligands, anionic ligands, for instance, like the chloride ion ends in O. So if this is a ligand, we call it chloro. Okay? If oxalate is a ligand, okay, and as you know, this is a bidentate, then instead of calling it oxalate, it's oxalato. It's because that tells you I have an anionic ligand. Okay? If I have just a neutral ligand, that's the name of the molecule. Now, what are the exceptions? So we don't just say water. All right? What we do is if you see H2O, it's aqua. All right? If you see ammonia, then it's amine. If you see carbon monoxide, then we call it carbonyl. So, however, if you see something like, what's another good one? If you see a ligand like, I'm just trying to find one that doesn't have that. Oh, like the ethylene diamine. That was just the name of the molecule. Okay. So, basically for water, ammonia, and my carbon monoxide, aqua, amine, and carbonyl. All right, so let's talk about these prefixes too. Okay, so when we do the prefixes, if we have monodentate ligands, then you're going to use di, tri, tetra, penta, hexa. Okay? So those are the prefixes that you use. Okay? So, meaning 2, 3, 4, 5, 6. If we have bidentate or polydentate ligands, okay, then basically you're going to put your ligand in parentheses, and you're going to have your prefix. And the prefixes you use are bis, tris, tetrakis, okay, and those go outside of your ligand. So you're going to have to differentiate between it's a monodentate or a polydentate. Okay, so let's try a couple of these. Okay, and at the very end, you're going to get the oxidation state. And that's in parentheses and Roman numerals. Are there any spaces? No, there are no spaces. So let's do an example of a couple of cations, and then we'll talk about the rule if your complex is an anion. Okay, so examples. All right, so let's do one. Okay, let's just do the cation. Okay, so we know we're going to name the cation. The ligands go first, and then it's going to be the metal, and then the oxidation state of the metal. All right, so the ligands. This is aqua. Okay, because it's water. I have 3 of them. Since this is a monodentate, it's tri. Okay. This one is a hydroxide. So we call it hydroxo because it's an anion. This one is a chloro. Alright, so those are the names of my ligands. Now, what about the oxidation state? So basically, the oxidation state, we know that if X is for my chromium, okay, plus 3 times 0, because water is neutral, plus hydroxo, though, is a -1, and chloro is a -1. And it has to equal the charge of my complex, +1. So, the oxidation state of the chromium has to be equal to +3. Okay? So we know that part. So now, we just have to put our name together. Okay? A, remember we do not include prefixes for this. So A comes first, then C, then H. So this would be tri-aqua. So just because we alphabetize off the A doesn't mean that we drop the prefix. Keep the prefix, but this is what you're going to alphabetize off of. So it's tri-aqua, chloro, hydroxo. Okay, so those are all my ligands. Then my metal, chromium, and then my oxidation state, 3, ion. So notice that there is all one word, no space. Okay, so that's how you go about it. Now let's try it with polydentates. So let's try something like this. Now, our ligand here, that's the abbreviation for ethylene diamine. Okay, and because it's ethylene diamine, we know this is a bidentate. And we know it's neutral. So, why is that important? So the reason that's important is if we look at nickel, the oxidation state of nickel is going to be +2. Alright, so let's go ahead and put things together. We don't have to worry about alphabetizing because we only have one type of ligand. But I have two of them, so we use bis. Notice it's bis and not di because it's a polydentate, or bidentate in particular. Then you put your parentheses, ethylene, diamine, okay, nickel, 2 ion, okay, all of it one word, okay. Now, when you alphabetize again, it would be off of the E if this were in a mix, okay. So, let's talk about anion complexes. So, follow all the rules that we just talked about. But the metal name, so your metal name ends in 8. And that's how we differentiate between the cations and the anions that if they're both complexes. Okay, so let's try an example. Okay, and then we'll, alright, so let's do this one. Okay. All right. That makes no sense. Okay. So, if we look, this is potassium. We said cation first. So, here's my cation, potassium. Now let's look at my complex. So, if you look at my complex, for this to be 2, this needs to be a -2, because we know potassium is a +1 charge, and I have 2 of them, so to be neutral, it has to be -2. In that case, we know nickel X plus 4, and the cyanide group is a -1 that has equal -2. So the nickel is going to be equal to a +2, okay, oxidation state. So that's good. Now, our ligand, we have tetra, because it's a monodentate. Cyano ends in an O, because this is a negative, has a negative charge on it. It's an anion. Nickel is my metal name, but since it's an anion, it has to end in an 8. So this one would be nickelate. And then my oxidation state would be 2. So your full name would be this. Potassium, and then a space, and then everything all in one word. Tetra, cyano, nickelate, 2. Okay, and that's how would you name this complex compound. Let's do a couple more examples. Okay? So let's do let's do this one. Okay, so we know chloride is a -1, so this, I have 3 of them, so this complex ion has to have a +3 overall ion charge. Okay, since this is neutral and that's neutral, then the chromium has a +3 oxidation state. Okay. So now let's name that. That's aqua. And I have 4 of them. So tetra. Make some space here. It's tetra aqua. And that's an ethylene diamine. And A comes before E, so if I put together, it's perfect. Okay, ethylene diamine, and then we have the chromium, 3. That's the whole name of my cation complex. And then my anion is chlorine. Okay, so that's the name of this compound. All right. Let's try one more. Let's try, do I want to do that one? Yeah, let's, actually 2 more. Okay, let's do this one. All right. In this complex compound, the bromide has a minus charge, which means that this complex itself has to have a positive charge. I'm going to just give myself a little space here. So we're just breaking apart our component ions. We can name this one, this is bromide. Okay, now let's go ahead and name this one. So BPY is bipyridine, and it is a bidentate. I have 2 of them, so I put a prefix, bis, in front of it. Okay? This one, the oxalate, is also bidentate. It's an anion, so we call that oxalato. Okay, so I have the names of my ligands. Now, the cobalt has an oxidation state of what? Well, X, I'll give you a different color. X for the oxidation state of cobalt plus a -2, this is neutral, so the -2 is just from the oxalate ion, has got to equal a +1. So X has to be equal to a +3. So now let's start putting this all together. This is my cation, so I'm going to name this first. B comes before O. That's the prefix. It's the bipyridine is the name of that bidentate. So it would be bis parentheses bipyridine. Okay. Oxalato. Cobalt. 3 bromide. Okay, and that would be the name of your compound. Now, if I say something like, well, what's the geometry around my complex? Well, is a cobalt-3. So just so you know, because you know it's cobalt-3 has a coordination number of N=6. So if I just say something like, oh, do you happen to know the geometry? You say, well, as a matter of fact, I do, because the coordination number is equal to 6 for cobalt-3. And you could just draw your octahedral. And you had a bis of bipyridine. Let's draw this nicely. We'll go ahead and put that one here. And then we have an oxalate. Okay, and this whole complex has a charge of +1. Okay, so this would be, if I asked you to draw it out, that would be the structure of bis bipyridine oxalato cobalt-3 bromide. Okay, so let's do one more example, and then we can start talking about isomerism. Okay, so the last example looks like this. Okay, now cation, anion. My cation is ammonium. What about my anion? So I have two of these. Ammonium's a +2. So we know that my anion complex looks like that, which means the oxidation state of my copper is going to be equal to a +2. So we're looking at copper 2. Okay, so ligand first, I have 4 of them. So tetra, bromo, right? It's not bromide, it's bromo because it's a ligand. Okay, they have 4 of them, and it's an anion, so it ends in O. And then we have to end in 8. So cuprate 2, and that would be the name. So ending in 8 tells me I have an anion. If it were a cation, it would be my ligand, copper, and then the charge. But since I have the end in 8, you're going to use cuprate. So the total name of this compound then is just cation anion. So it would be ammonium, tetra, bromo, cuprate 2. Okay, so let's move on to isomers.